Hello, in this video we'll be looking at capacitors and capacitance. A capacitor is effectively an electrical or electronic device that stores charge, and is represented by this symbol here as a capacitor, and it's represented like that, and meant to be two parallel lines, because effectively a capacitor is two conductors separated by insulator. So they can be thought of as metal plates, okay, and which are the conductors, and in the middle here is the insulator. And for a very simple rudimentary capacitor, it's just air. For others, they use other materials, but that's what a capacitor effectively is. It stores charge, and the capacitance of a capacitor is given by the letter C. This is the capacitance, so C is capacitance, and the capacitance of a capacitor is equal to the charge Q it can store divided by the potential difference that is put across the capacitor. Okay. Now the capacitance is given in farads. The charge Q, that's in coulombs, and the potential difference V is in volts. Okay, so this is the capacitor. Now, let's put here. So, in a simple circuit, we'd have our capacitor here, and let's put in a switch, and this capacitor would be connected to a power supply like that. And so this would be the positive, and this would be the negative. Now, upon closing the switch, we would complete the circuit. And what would happen, in fact, is you would find, so let's close the switch. There you go. As soon as the switch is closed, complete circuit, you'll find that electrons would flow from here, so E towards a positive plate, like that, and from here, electrons would flow from here, from the negative side, up to there. We get a flow of electrons, thus a temporary flow of charge, which would be a temporary current flowing. And what you would find, if electrons flow from there, you would get a positive charge on there, Q, and on this side, you would get a negative charge. Now, overall in the capacitor, there is in fact there's the same amount of charge there. It is in fact being separated, but in fact you separated the charge, so you could say you stored the charge, because once it's stored, it can be released, and all the Q there would flow back to there again. So we'll look at that. So we stored it all up. This is capacitor charge. So this, if this for instance here was 12 volts supply there, you'd get 12 volts across there. Okay, and eventually you've got 12 volts across there and 12 volts across there. The current would stop flowing, the electrons would stop flowing, and the capacitor would be fully charged with a potential difference between the plates of 12 volts, and a charge across it, the amount of, if you like, the total sum of the charge across it is equal to Q is equal to capacitance times the voltage, like that. Okay, so let's have a look at what happens when we are to discharge the capacitor. So just rub that out. Now, so imagine here we have our charged capacitor. We just charged our capacitor here. So we've got a positive Q there, negative Q there. And we're now going to disconnect it from the battery, and we're going to put the switch there. So we've isolated it from the battery, but this time we're going to replace the battery with a resistor R, so it gives it something to flow through. Okay, we put a resistor in the circuit, and we don't need to, but it's to delay it, and it's normal speaking to put a resistor in there. So if we then close the switch, what you would find is that the charge would then flow. Now, conventionally, we're going to do this conventionally. Conventionally, it goes from positive to negative. That's conventional current. So we're going to have a current flowing through here, or charge flowing through there. The amount of charge that will flow through there to get to this side to neutralize it would in fact be plus Q. So therefore, we're saying that the charge stored is in fact equal to Q, which is in fact the product of the capacitance, the ability to store this charge, which depends on the capacitor and the size of the plates, the insulating material between, multiplied by the potential difference that was put across the capacitor in the first place.